Welcome to this explainer. Right now we are seeing an absolute explosion in applications powered by large language models. But if you've ever actually sat down to build one yourself, you've probably realized that the real challenge isn't the AI, it's the plumbing. Without the right tools, you end up with this massive mess of spaghetti code just trying to get the model to talk to your database correctly. So today, we're exploring two of the absolute heavyweights in the open source AI development space, LangChain and LangGraph. We're going to break down exactly how they work, how they differ, and figure out which one is going to save you a major headache on your next big build. Okay, let's dive right into our roadmap. First, we'll meet the frameworks. Then, we'll look at LangChain as the sequential builder and LangGraph as the stateful maestro. After that, we'll put them head to head, and finally, we'll help you choose your ideal framework. All right, Section 1. Meet the frameworks. Let's cover the open source basics.
At the most fundamental level, both LangChain and LangGraph are open source frameworks specifically designed to help developers build apps using large language models. Instead of writing thousands of lines of messy, custom code to connect your data to an AI, which, let's be honest, is a total nightmare to maintain, these frameworks give you pre-built scaffolding. They make integration vastly easier. Think of them as the essential plumbing for the modern AI application.
Moving right along to Section 2, LangChain, the sequential builder. Let's talk about building in a chain.
So LangChain is an absolute specialist when it comes to executing a very specific series of functions. Imagine you're building an app where Step 1 is retrieving data from a website. Step 2, you need the app to summarize that exact data, and Step 3, you need it to answer user questions based entirely on that summary. In this scenario, think of LangChain like a highly efficient assembly line. The data moves logically from one station to the exact next station, always moving forward.
To build that assembly line, LangChain uses a beautifully modular architecture. You literally just plug together these high-level components. You might use a document loader to fetch your website content, and maybe a text splitter to chunk it down if the content is just too massive. Then use a chain to orchestrate the summarization, using prompts and LLMs. And actually, here's a detail I absolutely love. Because of this modularity, you aren't locked into one single AI provider. You could use a really fast, cheap model like Claude Haiku to handle the summary in Step 2, and then tag in GPT-4 for the heavy lifting of conversational answers in Step 3. It's incredibly flexible.
Now, the underlying structure of this LangChain process is what computer scientists call a directed acyclic graph, or a DAG for short. The big takeaway here is that tasks are executed in a very specific order, and they always move forward. Even if your workflow branches off for a second, like let's say Step 1 splits into Steps 2 and 3 before combining back into Step 4, the momentum is strictly forward. It's a highly structured, predictable one-way street, and that is incredibly powerful when you know the exact sequence of steps your app needs to take.
Shifting gears now to Section 3, LangGraph, the stateful maestro. Let's look at nonlinear workflows.
Now, it's super important to understand right out of the gate that LangGraph isn't actually a rival designed to replace LangChain. No, it's a specialized library sitting right inside that broader LangChain ecosystem. But its purpose is fundamentally different. It is built specifically for creating stateful, multi-agent systems that feature really complex, nonlinear workflows. Basically, LangGraph absolutely shines when the next step in your application dynamically depends on evolving conditions rather than a rigid, pre-planned sequence.
Let's look at a concrete example to illustrate this. Think of a task management assistant. This isn't a simple sequential chain anymore. Here, the user might want to add tasks, complete tasks, or summarize tasks in absolutely any random order. This entire dynamic workflow revolves around a central process input node that uses an LLM to understand what the user actually wants, and then routes the action to the appropriate step on the fly.
To achieve this kind of magic, LangGraph relies on three main structural components. You have nodes, which are the actions, like adding or summarizing a task, and you have edges, which are the pathways between those actions. But what's really interesting here, the true superpower, is state. This is a core component that maintains the shared context across all interactions. It's like having a master list of tasks that everything can look at. The add task node adds to the state, the complete task node checks things off the state, and the summarize node simply reads from the state.
Because of this shared state, LangGraph operates on a true graph structure, rather than the forward-moving DAG we talked about earlier. And what does that mean for you? It means it allows for conversational loops. The assistant can route out to a specific task node, update that persistent state, and then loop right back to the central process input node to wait for your very next command. It can revisit previous states in any order. This creates a highly adaptable conversational loop that feels way more like interacting with a human than an assembly line.
Time for the showdown. Section 4, the head-to-head comparison. Let's look at the contrasting dimensions.
Looking at their primary focus clears up a lot of the confusion. LangChain is basically an abstraction layer heavily focused on chaining LLM operations together to build robust, predictable applications. LangGraph, on the other hand, is completely focused on creating and managing multi-agent systems and highly complex workflows. Really, it's the difference between building a very smart, capable calculator versus building a fully autonomous virtual assistant. Structurally, remember that LangChain acts as a DAG, a highly efficient track that only moves strictly forward from start to finish. LangGraph operates as a true graph structure, built specifically to handle the messy, cyclical loops of human interaction, easily revisiting previous states based on whatever the user decides to throw at it next.
And hey, that structural difference directly dictates their state management capabilities. LangChain's state management is somewhat limited. It can definitely pass information forward down the chain, and its memory components can hold on to some conversational history, but it doesn't easily maintain a persistent, universally accessible state. LangGraph, however, is built fundamentally around that robust, core state component we talked about. Every single node in the graph can access, read, and modify that shared state at any given time, which allows for incredibly complex, context-aware behaviors.
Let's bring it all home with Section 5, choosing your ideal framework, making the right call for your project.
So how do you actually decide between the two? Well, if you are building an exact sequential process, like, say, retrieving a document and translating it, LangChain is absolutely your best bet for pure efficiency. But if you're building a virtual assistant that needs to remember context across long, really unpredictable conversations, LangGraph's specialized wheelhouse is exactly where you want to be. Now, interestingly, LangChain can handle non-sequential tasks to a limited extent using its own simple agents feature. But honestly, the moment you step into the territory of complex systems that require constant adaptation and a rock-solid shared context, you really, really need LangGraph.
Ultimately, both of these are incredibly powerful open-source tools that are totally redefining what we as developers can build right now. And remember, they don't compete, they complement each other by solving totally different architectural problems. So as you sit down to architect your next big idea, I want to leave you with this final thought. Will your next LLM project be a highly efficient sequential assembly line? Or are you building a complex, stateful multi-agent system? Let the structure of your idea dictate the framework you choose. Thanks so much for exploring this with me, and happy building.